Hey everybody, so today we're just going to do a very brief tutorial on the jit.gl.model object. Turbosquid.com is one of the websites where you can buy and download free 3D models. Another one is CG Trader. Max likes to import .dae and .obj files. Then they'll come right into Max. Note that .max files are for a different piece of software called Max. They have nothing to do with the Max that we're working with. They're for 3D Studio Max. So .obj and .dae are the files that we like. So we'll download a DAE file here. And save it to the class folder, and then we can find that file on the hard drive and just drag it right into the project, and there we have a 3D model that we can work with. And as we've looked at before, this file is just referenced in our project. If we open up our project folder here, notice that it's not inside our project folder until we say consolidate, and then it's moved. It's actually copied. A copy of the file is placed into the project folder. So you want to remember to consolidate before you move a project from one computer to another. Let's create a new file in our project. We'll call it Model Explorer. That creates file within our project, and it also creates that file within our project folder. And we're going to be making a jit.world. And a jit.gl.model. And turn on our world, and then we can drag and drop our model file onto the jit.gl.model, and it will import into our world, and that's a handy and quick way to bring a model in. But unfortunately, it won't stay there when we close the file and reopen it. And with this, you can do jit.gl.model @file low poly _tree _sample.dae. Turn on some lighting as well. And then once our model is in, it's going to respond in all the same ways that a grid shape does. So we can alter its rotation, its position, its scaling. We can also connect our model up to a jit.gl.multiple. And make lots of them. Jit.noise, as we've talked about, is a totally random number generator. It doesn't give us structured randomness the way that jit.bfg does. It just gives us static, if you will. So jit.noise 3. Let's make 100 trees. We'll make 100 trees in a 10 by 10 grid. Just so we can see what this jit.noise is outputting. If you want to see what's coming out, you can always use a jit.p window, and we'll look at these numbers as, this needs to be float 32. Yeah, so 100 random numbers organized in 10 rows and 10 columns, and we're seeing the numbers represented as colors. They're just values between 0 and 1 that we're seeing as red, green, and blue. But we're going to use them actually as positions. So we can drop that into a jit.gen. And as we've seen before, when we're dealing with normalized values between 0 and 1, such as jit.noise puts out, we do a standard -0.5, which converts this into a signed value from -0.5 to +0.5, and then multiply it by the area that we want to spread the objects over, say 10 meters, and Don't know why I went up to 24 points that time. And also need some scaling here. So we'll just give these some scale, like 0.3 of a meter. And there we go. There's 100 trees. Can use the jit.gl.handle to sort of take a look at what we've created here without needing to create a camera and move that around. Jit.gl.handle is dangerous though, because the jit.gl.handle will always reset when you close and open your patch. So it's much better to, when you're creating a scene, manipulate the camera, because the handle is just a convenience tool for looking at a different angle than the camera is showing us. So you always want to hit reset, because that is this view that we're seeing right here with the handle reset is what is gonna revert to when we close and reopen our patch. And there's no way to save that handle value, nor would you want to. You want to manipulate the camera. So let's take a look. I'm not going to go into too much detail about it, but just a quick look at how to use the matrix output. So at matrix output 1 is going to pass our model out of the object as a matrix. And so these colors that we see here are actually the points of the object. And then we can reconstitute them using a jit.gl.mesh that has to be in draw mode triangles. And we can see our object come back to life, except where it's not all there. Why is that? Let's turn on some lighting, enable. Well, it's because when we use the matrix output mode, the object's going to be split up into several groups if it was created in multiple groups. And this particular object was created in 2 groups, one for the top of the tree and one for the bottom of the tree. So we have another attribute called draw group. And draw group 1 is the bottom of the tree. And draw group 2 is the top of the tree. And I can draw these to 2 separate jit.gl.meshes, like so. And now our tree is whole again, but we're drawing the 2 draw groups separately. And if we want to combine those, I'll just show you one quick new object, which is jit.concat, which takes 2 matrices and sticks them together. We can concatenate these into a single matrix and thereby draw the whole tree with just one jit.gl.mesh. But sometimes it's nice to have each of the draw groups rendering to its own mesh so that you can, for instance, manipulate the color. We'll just do some sort of dark. This is the roots, so we'll just do some sort of brown. It's a nice woody brown. So I'm creating this color in the jit.gen, and similarly, I can create a color for the top. Here. And so that allows me to handle the 2 parts of the object separately. And if I want to put these into a multiple, I actually now need 2 jit.gl.multiples as well. I could feed them with the same gen, but I need a multiple bound to the tops and a multiple bound to the roots. And now I can create multiples of my processed geometry. And that's as far as I'm going to go. There's, of course, many more things you can do, but I want to get on to the homework assignment, which I will give you in a separate video.